I've made a game now that when you touch the ball, it gives you a point and it goes to a random position. Very nice. It spawns initially in a random position, and there you go. I'd like to talk about, let's say, for instance, some point in the game I come back and I'm like, I think I'd like this to be bigger. I'm going to make it quite a bit bigger just to kind of illustrate my point here now. Now, when it bounces off the wall, it goes into the wall. And the reason for that, of course, is because I've hard-coded, some of the values in here. Like this 10 represents half of this value, which of course now has changed. Now I would have to go through my code and go, oh boy, this 10, same thing, this 10 also, and make all these changes in my code. Okay, so perhaps a better way would be now instead to define a variable, and this kind of illustrates the practicality of using a variable. So just I'm going to say var ball size. I don't have, so it's round, it doesn't have a width and a height, so I can actually kind of just share them all in one. I could get all technical and go ball width and ball height, not necessary for this. I'm going to try and keep it simple. Equals, what did I say, 20, right? Okay, so now here, ball size, I can use that across the board here. So if it's greater than, now here, so it would be half of ball size, right? So here I can say ball size divided by 2, right? Same thing here. So I'm just going to copy this whole equation, ball size divided by 2. Another way to do it, would be to go ball size times 0.5. See, that's half of 1. That's kind of a nice way to think of it, because that's the same as 50%, 50% of 1, so I could say 40%, I could resize 20%, etc. I'm not actually resizing my ball just yet, so it might, to illustrate, I could, why don't I actually use my ball size there. Ball size here, ball size there. So there. So there. Now 50% of 1 gets bigger, bigger, Either way. So divided by 2 or 50%, which would be 0.50, or the zero is really irrelevant, 0.5. Okay. Ball size. So now, like I said, the trickle down effect here, this, same thing, ball size times 0.5 right here. Let me tighten that up. Same thing here, this one. Now, for here, there's a slight error in the code. I could illustrate now by turning the ball size way up and then maybe just pop it around a few times. And there, what happened? It got stuck in the wall. Okay, and the reason for that is should the random variable that you're generating, which is from 0 to 400, a very ballpark variable, right, just to kind of get you started quickly. But what could happen is your ball could spawn at, 2, or, in such a case, so that it's actually spawning inside the wall. Now what happens, like, it goes through one frame and it says if the ball X is, whatever, reverse it, and move it, 2 frames, 2 pixels, right? And then on the next frame, it goes through and sees that it's reversed and is still inside the wall, and changes it back and moves it, 2 pixels right back to where it is. So it's going to be stuck inside the wall, like that. You get this kind of little vibrating effect, not wanted. So technically here, instead of saying that we're generating a random value from 0 to 400, we would say, instead of from 0 to 400, like that, we'd say from the ball size, right here. Now watch this. Oh, I got an error. What's that? Ball size was used before it was defined. Oh, okay. I can't declare a variable down here, you see, and have it used up there. Oh, okay. Why is that? Because the computer is reading everything down. It's reading this line, then it's reading this line, and then it's reading this line. See, and here I have an equation. It says this: it's using ball size hasn't been read into memory yet. This variable does not exist in the computer's memory, and then it will go down, 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 go into the loop, the draw loop, and it will read this all the way down to here, and then go back up here and read. So you have to watch the order of things. See, okay. So that means if I want that ball size to be available up here, I have to declare it. I'm going to cut it and put it up at the top, and now it works. You can see I can put more than one line of code on the same line like that. The spaces, again, are irrelevant to the computer for the most part, so no biggie. There we go. So now I'm saying from, actually it would not ball size divided by 2, right? Or times 0.5, right? So here 400 represents the width of the screen, right? If I wanted to get technical, I could, with 400, there is a built-in feature. Like, for instance, if I had a game where I wanted to use a bigger size screen for whatever purposes, then I could check the width. There's a built-in value there of 400, right? So there, I would say width minus this amount. Whoops. Let me copy this bit. Copy. Width minus this amount, right? And just to make sure that everything is getting calculated correctly, I'm going to put that part inside parentheses. That tells the equation to, treat this as a single value. So it'll add it all up for you. Width minus half of the ball size. See, again, now all of this code trickle down will work fine. Same thing here. Let's see, ball size divided by 2. The whole equation, width minus ball size divided by 2. See, so here the 390 was the screen size of 400 minus the old ball size, which was 20, but now it's 40. So but there, width minus ball size divided by 2. Same thing here, width minus ball size divided by 2. Okay, so here we go. Random ball size, all of this, same equation here, yeah. And if I go all the way down here, oh, by the way, okay, so I can scroll up and down in the code like that using the bar. Or if you have a mouse wheel, as I do, I can scroll inside the window like that, So same thing here. Random, same thing here, random, see. So now I could change the ball size value up here in the code to anything, and it will bounce off the walls correctly, you see. And the beauty of that, see, it'll update everywhere along the line that I've used it in the code. Very nice. Save your program as a spin-off and name it collision detection.